Alright, let's get started. Section 2.3, Properties of Functions, is literally one of the most important sections in the entire book. Properties of functions. We're going to talk a little bit about certain properties. The first property we're going to talk about is how to determine whether a function is increasing, where a function is increasing, decreasing, or constant. And let's look at an example. Okay, first of all, I wanted to point out something. When we look at this graph, you'll notice lots of pairs of numbers within sets of parentheses. Those pairs of numbers represent the ordered pairs of the points that they're really close by. So let's say right here, -6, 0 is the ordered pair, are the coordinates of that point right there. -4, -2, and -2, 0, and so forth. So we see all these ordered pairs of the points around along the curve. Okay, and so for this particular example, we're going to determine where this function is increasing first. So look at where is the function increasing. So if you interpret the graph by looking at it and considering perhaps maybe you walk through, let's say you walk along some trails, you go hiking, and sometimes just like we read a book, we read from left to right, we walk along a graph on our paper from left to right. So if we picture walking from the leftmost point on this graph to the rightmost point, we start basically going downhill first, then we go uphill, then we're flat for a little while, and then we go back downhill. So the uphill part is the increasing, so it kind of goes along with that. So when you're going uphill from left to right, when the y values are getting bigger from when you move from left to right, we say the function is increasing. So this is the inequality notation, but here we have the interval notation, and this is not to be confused with all of these other ordered pairs here within the sets of parentheses. This is not an ordered pair. This is an interval along the x-axis. So I want you to make sure you write that. Interval along the x-axis. So that is how we answer the question, where is this function increasing? The function is increasing on the interval from -4 to 0. Okay, so that could be a little confusing when you look at that. Again, it's an interval. These other pairs of numbers are ordered pairs. Okay, so let's take a look here. Let's go ahead and draw a line underneath decreasing and then maybe a little arrow here. Maybe pause the video here. I'm going to tell you where the function is decreasing, but see if you can figure out what the answer is before I tell you. And you'd have to pause the video because I'm going to tell you right now. Okay, so the function, first of all, we start at the very left-hand side of the graph, and we say, oh, well, automatically we're going downhill here, and we're going downhill from this point here to this point here. And the interval on which we're going downhill, where's my red little pen? The interval starts at -6 and it ends at -4, but we also see we have another downhill section here. We're going downhill, the y values are getting smaller on the interval from 3 all the way to 6. Okay, so these are the two intervals on which this function is decreasing. Okay, then we have another interval on which the function is staying constant. And you can see it's the only other interval. That's constant would mean flat, like you're walking along a flat surface. And I don't have another color. Maybe we'll try this one here. So this function is remaining constant on the interval from 0 all the way to 3. Okay, 0 to 3. Now, what really does not make good video is to go through the definitions. So we may wait until class, but if you wanted to take a look at the definitions after we're done with the video, feel free to do that. Definitions here for increasing, decreasing, and constant. And then you've got a bit of a visual here also with basically the definitions in there. Okay, so that's property number 1. Where is a function increasing, decreasing, or constant? And I will start a new video for property number 2.